All right, we are on the second part of our proof practice, starting with number 5. In number 5, if we look at what we want to prove, we are first going to have to be able to prove our triangles congruent. So our first goal is to get to statement number 6 and be able to come up with a reason why our triangles are congruent. So let's do that part first, and let's start with the given information. So we have angle P is congruent to angle T, and that is given. Okay. And if we look at that, what we should see is that those are base angles. And so where we can go with that is then to be able to say that segment CP is congruent to segment CT, and that would be the converse of the isosceles triangle theorem, which is that if we have base angles that are congruent, that implies that we have congruent sides there. Now, from that, that's all that I can determine from that given piece of information. So I'm going to go to my next piece of given information, and that is that segment CU bisects segment PT, and that is given. And then once we are told that we have a segment bisecting another, that should trigger that we know that this point right here, U, is the midpoint of PT, segment PT, and that is the definition of what it means to have a segment bisector. And from that, then, once we have a midpoint, by that we could be able to say that segment PU is congruent to segment TU. And that's our definition of a midpoint. And so we have, and once we have that, now we have enough to be able to say that triangle CUP is congruent to triangle CUT, and that is by side, angle, side. Now, our goal was to be able to say that segment CU is a bisector of that larger, of the angles PCT. So to be able to do that, we needed these triangles congruent so that we can then say that this angle here and this angle here are congruent. And so we can say that angle 1 is congruent to angle 2, and that would be corresponding parts of congruent triangles are congruent. Now, once we have those congruent, we can now say that segment CU bisects the angle PCT. It bisects this larger angle, and the reason being is that that is a definition of an angle bisector. All right, so if we're looking at number 6 next, so if our ultimate goal here is to be able to say that two lines or two segments are parallel to one another, that's what we're proving. what we need to do is we need to be able to show that we have either corresponding angles or alternate interior, alternate exterior angles that are congruent. So before we do that, what we want to be able to do is get to step 8, where we have the triangles are congruent. Okay, so if we just take and we look at this figure, what we should immediately see is that we have vertical angles. And so you can either name them, or we can just take and number them, so that might be a little bit easier. And so the first thing that we want to say is that we have vertical angles. So angle 1, and angle 2 are vertical angles, and that is just the definition of a vertical angle. And then, of course, what we want to be able to say is that angle 1 and angle 2 are congruent. And so angle 1 is congruent to angle 2, and that is our vertical angle theorem. Okay, so we have that. And now we can start looking at some information here. And if we look at this information, we're going to have that segment ZT bisects segment AY, and that is given. If we look at what that would tell us and where that's located, what that's going to tell us is that O is a midpoint of segment AY. And that's just the definition of a segment bisector. From that then, once we are given that a segment bisects another, we immediately name the midpoint. And then from that, then we are able to say that we have segment YO congruent to segment AO. And that is our definition of a midpoint. And that is going to give us this to this. So we have a angle and we have a side at this point. And now we're going to go on to our next piece of given information, which was that O is the midpoint of segment ZT, and that is given. And if we're told that it's the midpoint, we're immediately able to just say that segment OT is congruent to segment OZ, and that is the definition of a bipoint, or definition of a midpoint. And so we have this to this. Okay. Now, if we look at this, you might notice that these two things went together, and these three things went together, and that these two things went together. And what that did was kind of build our angle and our one side and our other side. And so if we look at that, these three things can be, the order in which we did these things can be done interchangeably. So if you started with the given information, your steps 3, 4, and 5 might be up here, and then followed by the 6 and the 7, and maybe you didn't do the vertical angles until after. So as long as you have these groups together, that's fine. Okay, and it really, the way the problem was set up with some of the statements in there led you to go in that order. But if it was just a blank, you had to come up with the statements and reasons. I just wanted to be able to talk about how those can be interchanged. But we're now at the point that we can say that triangle ZOA is congruent to triangle TOY, and that would be by our side angle side. And so what we could do then is we can say that angle T is congruent to angle Z, because if we look at T and Z, those would be, the reason would be corresponding parts of congruent triangles are congruent. But what would really, that would tell us is that segment TY has to be parallel to segment AZ, because look at where those are located. The angle T and the angle Z, those are alternate interior angles, and that's one way that we can, if alternate interior angles are congruent, that is one way that we can prove that we have parallel lines. Note that up here in step 9, that we also could have just said that it's angle Y, that's congruent to angle A. That could have been another choice because that would give us those alternate interior angles also.